Whether you're analysing stocks, building machine learning models, or doing some data science, one skill appears everywhere: cleaning messy data. Let's learn how to do it properly with Pandas. So, getting right into, we have dealing with missing values. So, we're going to start off by creating the data frame that by the end of this video, we're going to have nice and clean. Here it is, a data set created like I showed in the previous video. A list of people with their age, gender, and salary attached. From just first looking at the data, we can see some missing values in the age column. Now, how to deal with this? Well, the first thing is to identify how many missing values we have in the data frame, which will run a true or false in each value of the data frame using .isNull. So we can do that, and then we do .sum at the end. That will count them per the column, with true counting as 1 and false as 0. Now that we can see we have one missing value in the age column, we now look at potentially replacing. First, we will need to do the age values aren't all numbers. The 30 is a character, for example. So to work with this age column, we first need to convert to numeric dfAge equals pd dot to numeric. There, dfAge, we can also see that I use errors equals coerce. This is so it will set any invalid values to NA. Now, what we want to change are NAs to. We can drop all rows that have missing values. This is with df.dropna, and we can see that the rows that had NA are now missing. They're gone. What else we can do with these missing values though? Well, we can fill it in with a number of our choice. So let's say we take the median age and fill the missing age value with that instead. So first we will identify the median age. Median age equals dfAge.median. Then to fill the missing values, we do dfAge equals dfAge.fillna, and then in the brackets we place our median age variable. So printing this will now show our missing values have been replaced with the median 30. Great. Those are two useful ways of dealing with missing values. How you deal with them is of course down to data science, and it is most importantly down to the context of the values and the data frame. What can be the next thing to consider when we are cleaning data? Well, duplicate rows can be next. We can deal with duplicate rows and drop them surprisingly easily. Let's first see if a row is a duplicate of another row before it. So let's do df.duplicated. This returns a short table of Boolean values that identifies duplicated rows. And we can see from here that row 3 is a duplicate. Now to drop that row, we can do it with only one command. df equals df.dropDuplicates. As easy as that. And now our dataset no longer has duplicates. Now, another thing to check is that all the columns are displayed as the correct data type. We will identify the data types for each column with df.dtypes. It will give us a list of the data types for each column being used. So first, let's go through the data types we could see. Int 64 is whole numbers. Floats are decimals. Boolean is our true or false. Object is either a string or a mix of data types. Date time is dates and times being displayed, and then a little bit more complex time delta, which will display a length of time, and then this is stored as nanoseconds and then converted to something more readable. For example, if time delta is 86,400,000,000,000 nanoseconds, then it will display this as 1 day. So we have to use these data types and make sure that the data types are fitting what we would expect for the columns. First name we have is an object. which in this case is a string. So this is fine. Age is being shown as a float, which is fine as we may need it to be a float for the median calculation. Gender is also being shown as an object, which we want to be a string, so that should be fine. Salary though is being shown as an object. So we know that that is not right, as it should be either a float or an integer. So we can change it like before. df salary equals pd.toNumeric. df salary errors equals coerce if there is potentially any missing values still. Commands similar to this, pd.toDateTime converts to a datetime data type, and toTimeDelta, which converts to our nanoseconds length of type data type. And then for changing to the other data types, we use .asType and place in the data type there, either bool or object, int64 or float64 if you would like to be more specific. Generally, use the pd.to ... functions when you're passing imported data, and then use .asType when you simply want to change an existing column to a different data type. Next up, let's have a little look at outliers. Now, there are a few different strategies of identifying outliers. Whether that is with variance or interquartile range, there are loads. Since I'm not showing how to work out outliers here, and just showing how to deal with them, for this code I will use the most simple way of finding outliers. The first quartile minus 1.5 times the interquartile range, and the third quartile plus 1.5 times the interquartile range as our outlier boundaries. So this code will go through identifying that. Start off with a for loop that will take on each column. Col equals df.select_dtypes, and then include number. This is so we only go through the columns that have a numeric data type. Otherwise, the outlier finding will break trying to find a interquartile range of strings. So we can find the quantiles. Q1 equals df col.quantile 0.25, and similar for Q3. Their IQR is of course Q3 take away Q1, and now take the lower outlier boundary Q1 minus 1.5 times IQR, and similar for upper bounds. Next, using the filter we used last video and a vertical bar that in this case works as an OR operator in Pandas, we take df col less than lower bound bar or df col greater than upper bound. This will give us the rows that have outliers in the column we are looking for. So now to display that to the user, print column outliers, then the column we are going through, and then print our outliers. When we do this, we display that we have two outliers in Tom's row, him being 200 years old and having a £500,000 salary. We have no good information to say that Tom can't have a £500,000 salary, so we can't really know if that is true, so we shouldn't remove it from the data. However, I have a slight feeling that he's not 200 years old, so I feel like now we can move on to dealing with that. So we could remove this row completely. Two strategies to go through. We can filter it out, print df age less than 120, let's say, so we can remove anyone who is way older than we would expect to see in a data set. We could also drop the specific row using df.drop index equals 4, as Tom is in index 4. Now you could maybe know what the actual age of Tom is. In this case, we can change it. And the way we can do that is with df.lock. This is to modify a row or column, and then square brackets, rows and column. So the row is where the age is 200 and the column is age. And this value in question will be set to 20 with equals 20. Then that is it. Now, the correct age is displayed in the data frame. Finally, we will deal with inconsistent text data. And what I'm particularly pointing to in this dataset is the inconsistencies with the gender column with capitals and such. So let's first check out what possible gender values we were given. This is using dfgender.unique. And this gives us the 3 different values given in our dataset. From a visual inspection, we can see that one of the male values given was in all caps and the other only has a capital at the M. And the female value given has a space at the end. So via inspection, we can figure out how to fix this. Remove the space with a .strip command as follows. dfgender equals dfgender.str.strip. Then convert all values to lowercase with .str.lower. This will fix all the problems we are currently having with that dataset. So now when we look at our unique gender values, it is just a simple lowercase male and lowercase female, which makes it much better for analysing with data science and doing statistics on. And then that is all we're going to go through for cleaning data today. If we print out the now clean dataset, it looks much more approachable and readable, which is the whole goal of cleaning data, which, as I said, is a priority before working with any new data frame. If you found this video helpful, please consider liking the video and subscribe to support the channel, and I hope to see you in another video.